Okay, last question. A particular test is used to measure how well students around the world can do maths problems. Mean score 400 and standard deviation of 60. Use the empirical rule to fill in the four missing values. So that's one standard deviation. So that's 400, 460, 340, and then um, so that's 280. I guess so. Use the normal distribution where the proportion of students worldwide who would score 420 on the test, above 420 on the test, give your answers to two decimal places. Right. Leaving cert formula book, please. Okay. Z is 420 minus 400 over 60. That is 20 over 60. That is 0.33. Tray 6293. So 6293. 6293. So more than is 1 minus 0.6293. So that would be 0.37 would score above 420. Yeah, not sure about rounding, but anyways. A random sample students taken from each country that takes part in the maths test table also shows the mean score and standard deviation for a sample from 3 of the countries, X, Y, and Z. It also lists the sample size of each. From parts B and C, use the relative standard deviation for the table above. Using values in the table, consider 95% for the population mean score for country X. X would be 387 plus or minus 1.96 sigma over root n. So that is 389.8. $384.2. For country Y, researcher carries out a hypothesis test at the 5% level to see if the population differs to 400. The null hypothesis that it was 400. The alternative was not. Use the Bayesian table work at the set score for this test. 403 minus 400 over sigma over root n. $2.22. For country Y. Hence work out the p-value. Right, the p-value, let's have a look here. 2.22. 2.22 is that. So in the tail is 1 minus 0.9868 times 2. So that is 0.0264. So P is less than 5%, so that means reject the null. In country Z, 50% of all students have a pet in their home and 50% do not. Describe how the sample of 252 all students from Z could be taken as a stratified random sample with respect to having a pet in the home, and explain why it's probably not useful to do this when looking at these students' math scores. Oh, leave me alone. Stratified. No, there's no link. I'm not gonna write anything. Blah 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 blah. Why on earth would having a pet affect your math scores, really? Blah blah blah. And what's the stratified random sample? That's not the quota one. Totally don't want to mix up now. Smaller subgroups. Oh yeah, strata. Shared characteristics. Yeah. Oh yeah. So it is. It's kind of like quota one. I don't know. Whatever. Put people into subgroups and select from subgroups. Select from subgroups of a desired trait randomly. I don't really want to write anything. This bores me. Let's just do the last question and get out of here. For one of the questions of the test, students are given marks of 0, 1, 2, or 3. The proportion of students who get marks is shown in the table below. If students picked at random, the expected value of their marks for this question will depend on the values of P and or. Find the largest value that the expected value of their mark could be. Right, okay, well, look, P plus 3 or has to equal 1 minus 0.19. So that's 0.81. And the expected value will be that, and then that, and then plus 4 or, plus 3 or. So the expected value at most is P plus 7 or. So the expected value, you want to make this a maximum. So that will be 0.81 minus 3 or plus 7 or. So the expected value is 0.81 plus 4 or. So what's the biggest I can make or? So remember, or is 0.81 minus P divided by 3. So the biggest I can make or is the smallest I could make P, which is 0. Expected at most 1.89. That would be the situation that has P as 0 and or as 0.81 divided by 3. I think that would be 0.27 and then 0.54 and 0.19. I guess maybe 0.89. Yeah. Yeah, you want to make P 0. That's not going to do anything. So the most can be set aside for these two. I guess.